Hey everyone! So today we're going to be talking about periodic trends. So some patterns that we see as we go across the periodic table from row to row and also down columns. So we are going to start by writing one definition at least. So we're going to start by talking about something called atomic radius. You guys probably know what the radius of a circle is. It's just the distance from the center of the circle to the outside of the circle. So, similarly, the atomic radius is basically the distance from the center of the nucleus to the outside of the electrons. But you can just think of it as something that measures the size of the atom. So that's what the atomic radius is. Now, we want to talk about patterns in atomic radius on the periodic table. So I'm going to show you a picture. So these are some of the elements on the periodic table. So like hydrogen and helium, here's lithium, all the way across to neon. So we want to write down what these patterns are for atomic radius. So as we go down a column, you can see that the radius gets bigger. So we're going to say increases down a column. And then if you look, as we go across, it actually decreases, which is a bit weird. And in class, we'll talk more about why that is. But you do need to know those patterns. Okay, now an easy way to remember this is to remember which atom on the whole periodic table would be the biggest and which one would be the smallest. So looking at this chart again, you can see the biggest atoms are going to be the ones like furthest down and to the left. So that element would be francium. So francium is going to be the largest atomic radius. I'm going to abbreviate francium as FR. And then the smallest is going to be on the opposite corner of francium, so helium would be the smallest. Okay, so that's one pattern you need to know about. The next one is something called ionization energy. So there's actually like a official specific definition of ionization energy, and it is how much energy it takes to remove a valence electron. Remember, the valence electrons are the ones in the outside energy levels. Okay, another way of kind of defining ionization energy is you can define it as how tightly an atom holds its electrons. So the higher the ionization energy, the more tightly the atom is holding its electrons. If it takes a lot of energy to take an electron off, that means the atom is holding that electron really tightly. So hopefully that kind of makes sense. Now I'm just going to tell you what the trend is on the periodic table. So as you go down a column, it gets easier and easier to take off an electron because there's more electrons. So the ionization energy decreases down. But as you go across, the elements are holding their electrons more and more tightly. That has to do with that the nucleus has positive protons in it. And the more protons you have, the more the electrons are attracted to them, the more tightly they're held. So it actually increases across. So this is the opposite of atomic radius, as you can see. So that means the largest and smallest are also going to be opposite. So the lowest ionization energy is going to be francium, and the highest is going to be helium. So again, that's because down over here, where we have lots of electrons and it's far to the left, that's where it's easy to take off the electrons, so low ionization energy. Up here, helium is holding onto its electrons so tightly, it does not want to get rid of them, so very high ionization energy over there. Okay, last trend we're going to talk about is something called electronegativity. And you can just think of electronegativity as how much an atom attracts electrons in a bond. So it's kind of like how much it wants more electrons. So electronegativity has a similar trend to ionization energy. As we go down, they have so many electrons they don't really want anymore, they don't attract anymore. But as we go across, we're getting more protons, and that pulls in more electrons. So electronegativity, just like ionization energy, is going to decrease as we go down the table and increase as we go across. But there is one weird thing with electronegativity. The noble gases have an electronegativity of 0. Even though they're like at the far right, they already have a full valence shell, so they don't want any more electrons. So noble gas electronegativity is 0. They already have all their electrons. So they don't want more electrons. Okay. So one more thing that you need to know, and then I'm going to show you a couple of examples. So when you're comparing elements, which is what we're going to do now, going down has a greater effect than going across. So let me give you an example. So here's an example. I want the highest ionization energy and my 4 options are going to be silicon, phosphorus, sulfur, and chlorine. So if I look at those, so silicon, phosphorus, sulfur, and chlorine. So we're looking for the highest ionization energy. We know that the ionization energy increases as we go across. So chlorine would have the highest ionization energy. Okay, another example, we want to rank the following from smallest to biggest. Atomic radius. Okay, and we've got lithium, potassium, cesium, and sodium. So those are the alkaline metals: lithium, potassium, cesium, and sodium. So from the smallest to the biggest atomic radius, well, we know the radius increases down. So lithium is going to be first, then potassium, lithium, then sodium, then potassium, and then cesium. So So we would write it out, Li, then Na, then K, then Cs would be the order. Okay, and then let me just show you an example on the periodic table. I'm not going to write this down, but sometimes we'll ask you questions about like 4 elements that are in a square. So let's say I wanted to figure out the highest electronegativity element of these 4, lithium, beryllium, sodium, and magnesium. So the ones that are further down automatically have the lowest electronegativity. So sodium and magnesium are both lower than lithium and beryllium. And then since beryllium is further over, it has the highest electronegativity. And the order, I guess from highest to lowest, would be beryllium would be highest, then lithium, then magnesium, then sodium. So hopefully that makes sense. If you have any questions, let me know.